Hi friends, I'm back with the numericals. As I promised you in the last lecture that this lecture will be devoted to numericals, so I'm back here. So I'm dealing with the first numerical. Okay, numerical. The first numerical is this: an object of height 7 cm is kept at a distance of 25 cm in front of a concave mirror. The focal length of the mirror is 15 cm. At what distance from the mirror should a screen be placed or kept so as to get a clear image? Next is, what will be the size and the nature of the image? See, I read it so fast, but you might not understand this numerical by reading in one shot. So what is your duty is to repeat it and read it thoroughly in such a way that you understand each and everything. So I will read this and make you understand each and every part once again. So look at this once again. I'm reading it. An object of height 7 cm means the height of the object, the size of the object is 7 cm. So look at this here, I've already done. H1 is 7 cm. Since we already know the sign convention, if you remember that H1 is always positive, so we have got 7 cm which is positive, right? Then it says that is kept at a distance of 25 cm. I mean the object is kept at a distance of 25 cm. Means I have been given object distance and the object distance is minus 25 cm, because we know that the object is always kept in front of the concave mirror, that is on the left hand side. So minus sign will be there, so it is minus 25 cm. Followed by next is the focal length of the mirror is 15 cm. Since it's a concave mirror, the focal length is negative, so f is minus 15 cm. Alright, what is to be found out next? Here is, says that at what distance from the mirror should a screen be kept? So what is formed on a screen? The image. So what I need is image distance. I need image distance. So here I want to find out V. V is the image distance, that is question mark. And to get a clear image, what will be the size? Size is H2. Okay, size of the image is H2. So which I want to find out. So here is H2 is the question mark. And then we have to find the nature of the image, how the image looks like, right? To begin with, here is, I have done the first part, that is given. I've been given this, I have to find out this. Now comes formula. Formula is nothing but we got two formula here. Is one is called as mirror formula, that is 1 upon V plus 1 upon U is equals to 1 upon F. And the second is M is equals to H2 upon H1 is equals to V upon U. So these are the two formula which we have, which we're going to use it in this to get the values of. See, the first formula which we're going to use, this 1 upon V plus 1 upon U is 1 upon F, is a mirror formula through which we are going to find V. And then we'll use this magnification formula to find the H2 and the nature, right? Let's use this formula without delaying it. So here is the solution. So solution, in the solution, using 1 upon V plus 1 upon U is equals to 1 upon F. So I want to find out V. So obviously 1 upon V will be on the left hand side, which is equals to 1 upon F minus 1 upon U. Now what I do is I substitute the values. The value of V is given already, the value of F is given as minus 15 here, and I carry forward the value of U as minus 25, and then I cross multiply. There are many ways of solving this. Either you can cross multiply or take LCM, whatever the ways you find it very easy, you can do it. I've done it by cross multiplying here. So I've just cross multiply. This is 25 multiplied by 1 is minus 25 here, because this is negative, and this is 15 multiplied by 1, so that is plus 15, and then I've subtracted minus 10 upon 15 into 25, and then I've cancelled. There is 5 2s are 10 and 5 5s are, and then this has become minus 2 upon 75. So 1 upon V, the value 1 upon V is minus 2 upon 75. So here is, I do the reciprocal of both the sides, so I get V is equals to 75 upon 2. So obviously negative sign is always going to be there, so minus 75 upon 2, and if I divide it, I get V is equals to minus 37.5 centimeters. So this is the value of V. So we calculated V. So our first thing is done. Now we are moving on to the second thing, that is H2. Okay, for H2 I'm going to use the second formula, that is magnification is equals to H2 upon H1 is equals to minus V upon U. So let's use this formula. So here is H2 upon H1 is equals to minus V upon U. I want to find out H2, so let the H2 be on the left hand side. So minus V upon U into cross multiply. H1 is cross multiplied to this, so H1. Now substituting the values, we found out V is minus 37.5, which I substitute here along with the minus sign which is already there. u is minus 25, which I substitute here. So it's become minus of minus 37.5 upon minus 25. So this minus minus is cut because upper nature is cut. So now you are left out with minus 37.5 into 7 upon 25. What do I do is I've tried removing the decimal from top. So I multiply by 10 in numerator and denominator. So I get 375 upon 250. This has become 250 into 7. I divide that. So I get here, if I divide by 5, so I get 75 on top and 50 down. If I divide by 25, 25 2s are 50, 25 3s are 75. So 7 3s are, that is 21. So it's minus 21 upon 2. And if I divide this also, I get minus 10.5. So when I get minus 10.5, this is the value of h2. That is the height of the image, which is negative. What does it mean? The negative means it is inverted. It's real and inverted. So the nature of the image is going to be real and inverted because this is negative. But still we have not found the nature fully. To find the nature, one more step we need to do is we need to find out whether the image is diminished, magnified, or the same size. For that we have done one more step here is m is equals to h2 upon h1. That is from the same magnification formula taken up. So here is minus 10.5 divided by minus 10.5 divided by 7, which I have solved, and I got the value as minus 1.5. Now this 1.5 is m, and this magnification is more than 1, means magnified. My image is magnified. So the total nature will be the image formed is real, inverted, and magnified. So the image formed is at a distance of 37.5, that is in front of the mirror. That is why this is negative. And here we got the height of the image as minus 10.5, that shows real and inverted. I've got magnification more than 1, which says magnified. So the nature of the image is the image formed is real, inverted, and magnified. Yeah, we are moving on to the next numerical, the second one, right? Second numerical is nothing but the B1. Okay, here these numericals can be found on the SSC textbook. Numericals you can find. This is the second numericals of their chapter. Okay, I read this numerical for you. The numerical says that a convex mirror has focal length of 18 centimeter. The image of an object kept in front of the mirror is half of the height of the object. What is the distance of the object from the mirror? I am sure you have not understood anything of this, and that is the first congratulation thing that you have not understood. So what you have to do is nothing but you have to reread this. If you reread, you will get few things out of it, because there are many things which have been hidden here which you need to find out. So for that you have to read it again. So when you're reading it, try comprehending the same, otherwise you will end up with nowhere. So the caution is, when you're reading it, you try and understand. Not able to read again, not able to understand again, reread it. But the thing is, you should be able to get the things very clear. So I'm reading it and simultaneously I'm making you understand. So a convex mirror has focal length of 18 centimeter. Very clear. I have been given focal length. Focal length is denoted as small f. That is f is equals to 18 centimeter. Now if you look at this, I have put positive sign here. It means it's a convex mirror, and the convex mirror focal length lies on the right hand side. That's behind the mirror. So it is positive. So I have put positive sign here. So the first line is clear. Second says that the image of an object, kept in front of the mirror, means the object which is kept in front of the mirror is half the height of the object. So that image which is formed is half of the height of the object, right? So what does it tells you? It tells you the size of the image, that is h2 is equals to half of the size of h1. h1 is the size of the object. The size of the image is equals to half of the size of the object. That is what is given in these lines. So you need to be very, very alert when you're reading it. The image of an object kept in front of the mirror means the object which is kept in front of the mirror is half of the height of the object. So half of the height of the object. So that means that the image which is going to be formed will be half of the height of the object, right? So what is now next part is what is the distance of the object from the mirror. So we have to find next is what is the distance of the object from the mirror, means at what distance you have kept the object from the mirror. So that's u, we have to find out u, that is object distance. So that we are finding out. The formula, obviously the formula which will be used is the two formula which we mentioned in the earlier sum. That is 1 upon v plus 1 upon u is equals to 1 upon f, and m is h2 upon h1 is equals to minus v upon u. That's magnification formula. What we'll do is here, instead of taking the first mirror formula first, I'm going to take magnification formula because my sum is little chaotic here. If you look at this data, I've been given h2 is equals to half h1. So I think that is going to be used somewhere here because I've been given no other data which is pertaining to this mirror formula right now. So I'll take the second formula, that is h2 upon h1 is equals to minus v upon u. I took this. Now look at this here, h2 upon h1. Let's go in the data. I've been given h2 is equals to half of h1, but I don't have h2 upon h1. So what do I do is, h2 is half of h1, so h1 comes here upon h2 upon h1, it is become, and that's equals to half. So I got the value of h2 upon h1 as half here, to which I'm going to substitute here, which is equals to minus v upon u. So substitute that half, and which is equals to minus v upon u. So what do you do next is nothing but, since you are finding out here is u, so you are finding out u, so you will keep your equation in terms of v. So what did I do is, I kept here minus v is equals to, and this u is cross multiplied here to this, so u into 1, so it's become minus v is equals to u upon 2. See, it's very important. Since I have to find u, I am keeping my equation in terms of v. If suppose I wanted to find out v, I would have kept my equation in terms of u. So here is, I know that I have to find out u, so I am keeping it as v equals to minus u upon 2. Now I am using the first formula, that's mirror formula here, 1 upon v plus 1 upon u is equals to 1 upon f. Right? Since you want to find out u, so your 1 upon u will be on the left hand side, this 1 upon v will move on to the right hand side. So 1 upon f minus 1 upon v. So let's substitute the values. F is given as 18, so I'm substituting f as 18, minus of 1 upon v. V is not there here, but v is here, that is minus u upon 2, which I substitute here, minus u upon 2. So if I solve it further, I get 1 upon u is equals to 1 upon 18. Now this minus into minus has become plus, so plus, and this 2 will go up in the numerator, so it's become 2 upon u. So 1 upon u is equals to, here, basically I wanted to find out u now, so 1 upon u is here and 2 upon u is here, so obviously I take it on that side, so this 2 upon u is gone to the left hand side, so it's become 1 upon u minus 2 upon u, which is equals to 1 upon 18. If I solve this is a very simple maths. Denominator is equal, so numerator, whatever the addition subtraction is there, will be formed. So 1 minus 2 upon u is equals to 1 upon 18. So this 1 minus 2 is minus 1 upon u is equals to 1 upon 18. So here u equals to minus 18. So when you solve it, take the reciprocal, so you get u is equals to minus 18 centimeter, and you're done. So now we are going to talk about the nature of the image. The object is kept at a distance of 18 centimeters because you have found u. U means the object distance. So object is kept at a distance of 18 centimeter from the convex mirror. So this is your overall of things. I think you must have understood this numerical also. Let's move on to the third one. Okay, C. So numerical C. Which says that a 10 centimeter long stick is kept in front of a concave mirror having focal length of 10 centimeter in such a way that the end of the stick closest to the pole is at a distance of 20 centimeter. What will be the length of the image? See, the sum is so confusing, but you don't have to confuse. I told the remedy is to read the sum again and again, and if you read the sum again and again, you will get the entire values with you. So let's read it again. A 10 centimeter long stick is kept in front of the concave mirror. So 10 centimeter long stick means what? A stick which is 10 centimeter long means the size of the object is given to you. So size of the object is nothing but, we denote it by h1. h1 is equals to 10 centimeter and h1 is always positive. Okay, so it is being kept in front of the mirror, having focal length of 10 centimeters. Since a concave mirror, we know that the focal length is always negative, so f is equals to minus 10 centimeter. The reason I've mentioned here, concave mirror, focal length is always negative, right? Here says that in such a way that the end of the stick closest to the pole at the distance of 20 centimeter. Means whatever it is talking about is only saying that the object is kept at a distance of 20 centimeter. That's it. Means you have been given u is equals to minus 20 centimeter, means object distance. Whatever is closest to the pole and always been given, but it only says that the object is kept at a distance of this much from the mirror, so that is minus 20 centimeter. Right? So you run with the data. So data is h1, f and u. Okay. Now says that what will be the length of the image. Means you want it wants you to find out height of the image, that is h2, nothing else. It is only telling you what will be the length of the image. Length of the image means size of the image, that is h2. Right? Let's talk about the formula. We're going to use two formulas, though we have to find out one only, but then we have to use both the formula. That is 1 upon v plus 1 upon u is equals to 1 upon f. M is h2 upon h1 is equals to minus v upon u. So this is mirror formula, this magnification formula. Right? Okay. What we do is first let's find out v. Once we find v, then it will be easy for you to find out h2. Because supposingly you want to take this formula only. So here you have got h2 to be found out, h1, v and u. But look at the data, you have got u and h1, but you don't have v. So you have to find out v. There is no option for you. So here is 1 upon v plus 1 upon u is equals to 1 upon f. So 1 upon v, now let's substitute. Plus this u ka value is given as minus 20, fine, is equals to 1 upon f is given as minus 10. So here is, since I want to find out v, let 1 upon v on the left hand side and this entire thing go on the other side. So here is minus 1 upon 10. This was minus because plus minus is minus, so if you go on the right hand side it becomes plus. So plus 1 upon 20. What did I do is nothing but here is I take an LCM instead of cross multiplying. I take an LCM, that is 20. So here is above is minus 2 and plus 1. I hope you should know how to solve this. This is 20, LCM of 10 and 20. So if I divide 20 by 10, I get 2. And that 2 will be multiplied in the numerator. So 2 into 1 is minus 2. Similarly, here is 20 will be divided by 20, which comes as 1. 1 will be multiplied in numerator. So 1 into 1 is 1 only. So it's minus 2 plus 1. So 1 upon v is equals to minus 2 plus 1, which is minus 1 upon 20. So v is equals to minus 20 centimeter. This is your v. See, we never wanted v, but then we have to find it because the demand of the formula. So now let's go for the next formula, that is m is equals to h2 upon h1 is equals to minus v upon u. So here is, you want to find out h2. So let the h2 be, h1 ka value substitute here from here, that is 10 equals to minus v. Just now you calculated, that is minus of minus 20 divided by u ka value is already there with you, it is minus 20. So here is minus 20. Okay, what we do is, let's solve this. h2 upon 10 is equals to this minus minus 2 goes. So above you left out with minus 20 upon 20. Now 20 and 20 that is also goes 22. So you are left out with h2 upon 10 is equals to minus 1. So finally the value of h2 is equals to, here let's cross multiply this, 10 will be multiplied with 1, so that is going to be minus 10 centimeter. So the value of h2 is equals to minus 10 centimeter. So the height of the image is 10 centimeter. Though the value is minus indicates it's inverted. Okay, so we will not be writing in the final answer, we always write 10 centimeter because the distance is never negative. So here the minus sign only indicate that it's real and inverted. So the height of the image is 10 centimeter. This ends with this numerical, that is C from your textbook. Thank you. Alright, so moving on to the last numerical of this video, right? Very important, very big also, you can see that it looks very big. Right, says that Rashri wants to get an inverted image of height 5 centimeter of an object kept at a distance of 30 centimeter from a concave mirror. Okay, if you have not understood the sum, you reread it. And I always advise you that you want to do the numericals, you have to reread the sum till you understand the data. Okay, Rajshri wants to get an inverted image. She want to get an inverted image, okay, of height 5 centimeter of an object kept at a distance of. So here I have been given height as 5 centimeter of an object. Okay, so here is, she wanted to get the inverted image of height. So inverted image means I want to know I have been given the height of the image, which is minus 5 centimeter. Why? Because this image is inverted, that is she is expecting to get, right? So inverted image, so that is why negative sign here. Okay, says that kept at a distance of 30 centimeter from a concave mirror. So that the image which she has obtained, that is she is expecting, that is -5 centimeter, okay, is that object is kept at a distance of 30 centimeters. So u is equals to 30 centimeters. Since u lies on the left hand side, that is in front of the mirror, so u is always negative. We know the sign convention, -30 centimeter. Okay, the focal length of the mirror is 10 centimeter. Saying that focal length of the mirror, this is concave mirror, so the focal length will always be negative because it lies on the left hand side, which is nothing but the front of the mirror. Okay, so concave mirror, that is focal length is negative, so -10 centimeter. Next, what it says, what will be the type of the image and what will be the height of the object. So here it's talking about, we have to find out the height of the object. Okay, so here is a small correction which is coming. Here is, instead of h2 we are finding h1. Okay, one small correction, h1, and we want to find out v, and then we can state the nature of the image, right? Okay, to do this, same, we got two formula, that is the mirror formula and the magnification formula both, right? We are going to use it. So let's use the first one as the mirror formula, because here is v, u and f. So I've been given u and f, so I can find v easily. So 1 upon v plus 1 upon u is equals to 1 upon f. So 1 upon v is equals to 1 upon f minus 1 upon u. So it is 1 upon f. F ka value is -10, here substitute it. U ka value is -30, which I substitute here, and then I solve it. This minus into minus is plus. Okay, this minus will remain here, it will go in numerator. So -1 upon 10 plus 1 upon 30. Now you can cross multiply, or whatever the way you want to solve, you can solve, but I have cross multiplied here. 30 into 1, that's -30. 10 into 1, that's plus 10 here, upon 30 into 10. So here is -30 plus 10 is -20 upon 10 into 30. So here is, now you can solve this. 10 ones are 10 twos are, right? 2 ones are 2, 15s are 30. So you got the values 1 upon v is equals to -1 upon 15. Now if I do the reciprocal of this, so it has become v is equals to -15 centimeter. So you got the value as v is -15 centimeter, but this is not all. We want to find out the h1. So for that we have the formula, m is equals to h2 upon h1 is equals to -v upon u. So m is equals to h2 upon h1 is -v upon u. h2 is equals to -v upon u into h1. So substitute the values. Just now we got the value as v as -15. So I substitute here minus of -15 upon u. U ka value is already been given here, -30 into h1. Okay, into h1. Since we do not have h1, so let it be h1 here, into h1. Okay, what we do next is we solve this part, minus 2, because that's cancelled. Now here 15 ones are 15 twos are. So 15 ones are 15 twos are, that's become -1 upon 2 into h1. So we have sorted things a bit. Now what we have is, we have a h2 ka value. h2 ka value is going, already we have got -5, which I substitute here -5. This is equals to -half into h1. कोई तकलीफ है नहीं है. So this is -5 into, now let's cross multiply, -5 into -2, and here you are left out with h1. So obviously h1 is equals to -5 into -2 is 10. So h1 is equals to 10 centimeter. You getting the value of 10, the h1 as 10, positive 10, which says that your numerical is already right, because h1 is always positive. So what is the answer then? The height of the object is 10 centimeter. Thus the image will be real and diminished, because our image which is formed is real and diminished. Okay, so your object is 10 centimeter, image is 5 centimeter, which is smaller, and it is negative, which shows that it is real and inverted. So the height of the object is 10 centimeter. Thank you very much for watching this video, and keep watching my channel, and subscribe my channel if you have not done it, if you are coming for the first time. Wait for the next video. Thank you so much.